Hey everyone, and welcome back to PrepFusion. I'm Anish, and today we'll solve the network theory portion from the Gate 2024 of Doubly branch. So yeah, the questions actually were pretty good. I got to see all of the questions. So yeah, they were pretty good. Few questions were actually very lengthy, and few questions were very tricky. Like what will happen is that if someone has just mugged a formulas, he will get tricked in that. He will just write the formula equation and just put the answer, and that will be wrong. So in that perspective, question was definitely difficult. What I will say is the question difficulty level was almost like the previous year, but not like that, or not totally like that. It was, the difficulty level was bit lower than the previous year KW paper. So yeah, definitely it was very tough, very difficult, but it was not exactly like that, like the previous year. It was somewhat lesser than that. The difficulty level was somewhat lower than that. But it was very lengthy. This year the paper was very lengthy. Okay, the core questions were also very good, and this non-core questions were also very good. So in network theory, total 5 questions came, okay, from the W branch. So we'll just solve them right away. So this first question is very simple. So the circuit shown in the figure with the switch open, okay, circuit is shown with the switch open. After the switch S is closed, the time constant of the circuit in seconds. So you have to find the time constant of the circuit in seconds when the switch S is closed. Simply what you do, you can remove the independent sources and just find the L equivalent and R equivalent. As we have only one time constant, we definitely know that the inductors, the voltages or currents will be somewhat dependent with each other. So here what do we see? Obviously these two inductors are in parallel, okay, the voltages are same, hence what will happen? Again, these two inductors I can write in ones is that 0.5 Henry. Inductors just act like resistors, okay, and capacitors just act opposite. So here if capacitors were present, then it would have been just doubled instead of being halved. Okay, so yeah, this is one case. Now this becomes 1 Henry, and this becomes 1 ohm, and this becomes 1 ohm, and this becomes 1 Henry. Okay, and the switch is closed. Obviously the independent source is opened, like the made zero, effect of it is made zero, so current source will be open. So what do you see? The current through this, all of these are same. So obviously these three things are in series, these two things are in series, so this will become simple 2 ohm and 2.5 Henry. So what will be my tau? Tau will be my L equivalent by R equivalent, simply 2.5 by 2, which is equals to 1.25 seconds. Okay, and your answer will be 1.25 only. Okay, answer will be A, option A. Okay, so this one was pretty simple. Now this question is again like simple only, but few people got confused with this. How did they get confused? Like they got confused between junctions and nodes. Just wait a second, let me check if yeah, everything is recording or not. Yeah, they got confused between junction and nodes. So what is a junction? Junction is where more than 3 or more elements are present at that point. So junction, 3 or more elements, and nodes mean 2 or more elements. So they got confused between nodes and junctions. So for junctions, let us first try to understand how many junctions are there. That is what the question is asking. So the number of junction is simply, first here how many elements we have? We have only 2 elements, right? So this is not a junction for us. At this point, how many elements we have? We have 3. So this is one junction. Again here we have 3 elements, this resistor, inductor and capacitor. So this point has, this is also another junction. Again if I see this point also is a junction. Again if I see this point, resistor, capacitor, so this is a junction. Again this point is a junction. Again this point is a junction. Okay, now many students got confused between this. They thought this one is also a junction, but this one is not a junction, because here I don't have any element, only a wire is present. Here I have an inductor, here I have an inductor, so only I have 2 inductors. So this is not a junction. So total number of junction is 6. So my answer will be B. Okay, the answer for this question will be B. So these two questions were like simple only. Okay, this one was just, if you recall what is junction, that is like that is the main crux of this question. Now all the elements in this circuits, now this next question is, all the elements in the circuits are ideal. The power delivered by the 10 volt source is in watts is. So this is again, like some people got confused, like if alpha is present, how will you find power delivered? So if you just write down, right, you just start writing, start solving, then automatically the solution will come up. So this one is very simple. You just write a KCL equation at this node. So write a KCL equation at this node. Assume the potential V over here. So V minus 10 divided by alpha plus V by 1 plus, now this is, here there is a current source in series with this 2 ohm, so it doesn't matter, we can neglect it. So this 10 amps will come inside. So if this 10 amps is incoming, so I will write this as incoming is negative for me and outgoing is positive for me, equals to 0. So V minus 10 and V minus 10, what I can do is 1 by alpha plus what is this, yeah, plus 1, okay, equals to 0. Now what do you know is, this is a resistor and they haven't talked us anything, like all the elements in circuit are ideal. So this is a simple resistor, passive element, and resistance can't be negative, so alpha has to be greater than 0. Now if alpha has to be greater than 0, then this has to be greater than 0. If this has to be greater than 0, then this, like this can't be equal to 0, this can't be equal to 0, then this has to be equal to 0. So V has to be equal to 10. Okay, so if V equals to 10, like we have to find the power delivered, right? We have to find the power delivered. So what is the power delivered? If I assume some current I over here, the power delivered by 10 volt will be V times 10 times I. Okay, now what is the current I? V is my 10. Okay, V is 10. So what is the current I? I is 10 minus this 10 divided by alpha. So this is 0 only. So I is 0, because I is 10 minus 10 by alpha, which is 0 amps. So my power delivered by the 10 volt voltage source will be 0 watts. So answer to this question will be C. So yeah, this was again like pretty simple. So just try to write equations. Now this one is a very good question. Now there is one formula for this which we like recall, but if you just can see this, that this part, right, this part will go into the resonance. So if this part goes into the resonance, then this will just be short circuit and simple ZTH will be just this 4 parallel with 2 and 4. Okay, if you can't recall that, then you have to apply the formula. So if we have like the formula with some mutual inductance, because this is not an ideal transformer. So here if we have a transformer like this, okay, and this is L1 and this is a mutual inductance is M. Now my Z in of this, Z in dash of this transformer, looking in impedance to the primary of the transformer, will be simply ZXL1 will be obviously here. Okay, and this inductance will also be there. This is a huge derivation. I'm not, obviously we don't have time for this. So this will be omega M whole square divided by J into XL2 plus, now if some impedance is also connected over here like this, ZL, okay, this will be equal to this ZL. Okay, so this will be my like looking in impedance at this terminal. Okay, so now if you put these values, what is your XL1? XL1 is simply this J into 125 into 5 million 1000 gets cancelled because we have been given 5000 radians. Okay, so this is one thing, and like you have to find the Thevenin impedance, that is why I'm doing all this. So next is this one. So omega m square is simply, omega is 5000 and your m is 5 milli, so this will become only 5 into 5. Okay, and simply what will this become? Whole square, and this is what, this is how much, this is ZL. So my ZL in this case is how much? ZL in this case is 1 by omega c 1 by j omega c, which is 5000 550 into 10 to the power minus 3. So this becomes, this goes above 10,000 upon 250, which is 4j minus j4, and this is already how much? This is simply j5. So this is simply j5. Okay, like 5,000 into 1 milli equals to j5. So j5 minus j4. So this will become simply plus j. So j will go above. So this will be j125 into 5 minus 25 ka whole square, which is 625. Okay, so again this becomes my zn dash, which is equals to 0. So at that frequency we are getting resonant condition. Obviously this is becoming 0. So this we can replace with this with a short circuit. So my overall circuit will become something like this. This is 4 ohm. This is 4 ohm. This is 2 ohm. Okay, so overall this will be like a short circuit. Okay, so this will be simple answer. So it will be 4 times 2 divided by 6 plus 4, which is simply 4 plus 4 by 3, 1.33. So it is 5.33. Okay, so my answer to this question will be 5.33, rounded up to 2 decimal places. Now the question that all of you have been waiting for, this question, like this is a very good question. Okay, two passive 2-port networks are given, P and Q. Okay, for which the Z parameter is given for the P and the Y parameters are given for the Q network, and you have to find like the overall ABCD matrix of the overall network is given like this. Okay, alpha, beta, gamma, delta, and you have to find the value of beta in ohms. So yeah, I in my thumbnail, as I mentioned, you can solve this within 2 minutes. Obviously if you know a few things, then you can solve it, but still it will take me some time to explain you everything and that all those things, right? So don't get angry or something. So now, like how to approach this. So if I see this question and if I start to attempt this, I am saying that this is very lengthy. This is taking me more than 2 minutes. I always say this, that solving now and solving in the examination is completely different. Okay, so teachers will solve now in front of you, yeah, so easy, so all those things, but that's not the reality. When you are in the exam hall, the pressure is different, mind won't click, everything won't be perfect. So in the exam hall, what should you do during this type of question? In the exam hall, what I would have done is, I would have, like, if it is taking more than 2 minutes, directly skip it, don't need to do it. Whichever question in the gate exam is taking more than 2 minutes, you should skip right away. If you are in the first round, just solve the easy questions which are doable. Okay, then you come to the second round, then again you try to solve this. What will happen is, maybe this question will remain in your subconscious mind, and some trick or something may came up. Okay, something may come up that, okay, I can solve like this also, like something will click in your mind. Okay, maybe I was solving in the wrong direction, that's why it is taking me more time. If I solve this in this direction, it will take me less time. Okay, even though this is a lengthy question, definitely this question is lengthy, but still. Okay, so whenever these types of questions come up, always skip this in the first round. You solve this in the second round, third round. These are just to waste your time in the first round. Okay, don't do this. So now how to solve this? So basically I will explain you, so it will take me some time. So first thing is, if we know the ABCD parameters of this P network and the Q network, the overall ABCD parameter will be simply the matrix multiplication, because they are in cascade. That is known to everyone. Now, what is the another concept? So if the ABCD parameter of the first network, P network, is A, P, BP, CP and DP, and the second network is AQ, BQ, CQ and DQ. Okay, now if I do the matrix multiplication, what I have to find? The first element will be AP, AQ plus AP, AQ plus this AP plus BP into CQ. Sorry, I'm doing some mistake. AP into AQ, yeah, AP into AQ plus BP into BQ. So PP into CQ, sorry, BP into CQ. Okay, and the next AP into BQ into BP into DQ. So AP into BQ plus BP into DQ, and this is my alpha element. I'm just explaining you, this is my beta element. So that's what you have to find. So you don't need to find all the ABCD parameters of each P and Q network. If you just find the A and B of P network and B and D of Q network, you are good to go. You can find beta, and that is what they have asked. So now what I used to do is, like, I always forget the relationship of ABCD parameter. So it will take you 10 seconds and it's fine. It's fine. You waste 10 seconds in these questions because this will fetch you marks. Okay. So if you are in the last round, so I tend to forget the ABCD parameters, all those things. So what I do is I simply write the equations and do like remember one thing, that also take care of the notation. So for ABCD transmission line parameters, if you have some network like P network, then you take your current like this. Okay, you take your current like this. The convention is like this. But if you are writing your currents incoming to the two ports, then your equation, ABCD equation, will change. So what will the equation be? It will be simply, first I recall that, yeah, it is a function of V2 and I2, the output parameters. So obviously they are the independent variables, so they will come here, and the dependent variables will come on the left hand side of the equal sign. So obviously dependent variable are V1 and I1. So I will write V1 and I1. I know the independent variables are V2 and I2. So first obviously will A come, and then what will happen? V2 and I2. So V2 will come then, and then minus will come, because I have taken the I2 sign incoming to the node, incoming to the port, but for transmission parameters it is outgoing. Okay, outgoing, because like in transmitter line the convention is that outgoing, like this current will be outgoing, okay, not incoming. So this will be minus B into I2 equals to, this will be C again, so C V2 minus di2. So I also tend to forget this ABCD parameter, so that's how I remember. I just write this down. Okay, it's fine, it will take you 5 seconds, but that's fine. At least you will do your question correctly. Okay, so now what will be my A value, B value, and C and D value? So for A, what you like, first thing you can do is make I2 0. If you make I2 0, your A will be V1 by V2, and your C will be I1 upon V2. And if I make V2 equals to 0, then your B will be minus V1 upon I2, and your D will be minus I1 upon I2. Okay, so this will be my B and D, A and C. So I am interested in this, so I will always try to make either I2 0 or V2 0, like for A and C and for D. Okay, so not for C, sorry, for A and B and D, not for C. I'm not interested in C. So like next, what should we do? Now we have been given the Z parameter of this P network. So let's just write the Z parameter in terms of equation. ZP equals to 40, 60, 80 and 100. So this will be V1 equals to 40 I1 plus 60 I2. Here the independent variables are I1 and I2. It is Z parameter, so the ratio will always be what? Ohms. Okay, and here V2 equals to 80 I1 plus 100 I2. So this question was difficult because NAT was there and you didn't have the options to like check all those things. So yeah, definitely this question was lengthy and difficult. So now what you do is you have to find A, B and D. So for finding A, you make I2 0. So if you make I2 0, you will get V1 equals to 40 I1 and V2 equals to 80 I1. So my A, now this is AP basically. AP equals to this V1 upon V2, which is 40 upon 80, which is 1 by 2. So AP equals to 1 by 2. Now we have to find next what? We have to find BP. So for BP I have to make V2 0. So for BP I have to make V2 0. If I make V2 0, V2 and B is equals to V1 upon minus I2. So B is equals to V1 upon minus I2, and we have to make V2 0. So if I make V2 0, my I1 will be equals to 1.25 I2, and this is a negative sign. So obviously if I make V2 0, here V1 will be in terms of I1 and I2, and I want V1 upon I2. So I will write I1 in terms of I2 so that I can replace it over here, and then I can find my answer. So replacing in the first equation, so V1 will be equals to this 40 times 1.25, which is minus 50 I2 plus 60 I2. So my V1 by I2 will be equals to 10, and we have to also put a negative sign. So B is equals to minus 10. So B is minus 10, that is one thing. Now this is B, P. Now let's find the parameters for Q. So for Q, what we need to do, Q network, you have been given the admittance network, admittance parameters. So the admittance parameters are 5, minus 2.5, minus 2.5 and 1. So 5 minus 2.5, 2.5 and 1. Okay, 5 minus 2.5, sorry, these are okay, both of them are minus 2.5. Now next what you do, next basically you again write the equations. So this will be, again this is the admittance, so this will be in terms of I1 and I2. Here this is I1 and I2, so this will be 5 V1 minus 2.5 V2 minus 2.5 V1 plus V2. Now what we do, now you simply find these two parameters, right? You have to find B and D. So what is B and D? Just make V2 0 and you will get B and D. So B is again minus V1 upon I2, and you have to make V2 0. So V2 0, so if I make V2 0, so I1 will be equals to 5 V1 and I2 will be equals to minus 2.5 V1. So the ratio what I have to find is V1 upon I2. So V1 upon I2 and the negative, okay, so yeah, negative is also there, equals to 1 by 2.5. So this is my B, Q, and I have to find DQ. So DQ is simply what? DQ is I1 upon I2. So you have to take the ratio of these two, I1 upon I2. So this will be minus 2. Okay, so this ratio is minus 2. Yeah, sorry, this is a minus I2 upon I1. So yeah, I just so this is minus I1 upon I2. So this will be, I was just making like what mistake I'm making here. So this will be simply minus I1 upon I2. So this is simply 2. Okay, so now what will be your answer? Your answer is AP into BQ plus BP into DQ. So AP is 1 by 2, BQ is 0.4, BQ is 0.4, 1 by 2.5 is 0.4, plus BP is minus 10, BP is minus 10, and your DQ is 2. So like even I am doing so many calculation mistakes, so I do like understand, yes, this is like a difficult question, like difficult in terms of lengthiness and like so many things you have to write, right? So it is bound to happen that you will make some calculation mistake here. So it will be minus 19.8. so this will be my answer for this question. Okay, the answer for this question was minus 19.8, rounded off to 2 decimal places, so it will be minus 19.80. so this will be the answer for this question, beta. So yeah, electrical paper was on the like tougher side, the lengthiness was very high. So yeah, I think after like seeing more of the questions, I can like again give a revised rank prediction. Okay, so thank you for watching, and I will see you in the next video. If you like this like the content and all those things, then do hit the like button, and I will come up with the iron network theory solutions. Thank you.